The ether theory. The attempt to describe nature mathematically had, as a result of Newton's efforts, attained a great measure of success so far as the phenomena of motion were concerned. All the main motions of the celestial bodies had been given a satisfactory mathematical description, and many of the motions that occur on the surface of the earth had been equally well described. But there remained a vast range of phenomena for which a mathematical description had not yet been given. There were the phenomena of light and heat, and of the electric and magnetic attractions. Other things that puzzled Newton were why two well-polished metals cohere in a receiver exhausted of air, why mercury stands sometimes up to the top of a glass pipe, though much higher than 30 inches, why the parts of all bodies cohere, also the cause of filtration, and of the rising of water in small glass pipes above the surface of the stagnating water they are dipped into. He also wanted to know how all sensation is excited and how the members of animal bodies move at the command of the will. For all these phenomena, Newton had recourse, provisionally at any rate, to the notion of an ether, a notion that was destined to become one of the major scientific concepts. Newton's conception of the ether underwent various modifications, but it never advanced sufficiently far to receive mathematical formulation. He outlines an early idea of it as follows. It is to be supposed that there is an ethereal medium, much of the same constitution with air, but far rarer, subtler, and more strongly elastic. But it is not to be supposed that this medium is one uniform matter, but composed partly of the main phlegmatic body of ether, partly of other various ethereal spirits, much after the manner that air is compounded of the phlegmatic body of air intermixed with various vapors and exhalations. For the electric and magnetic effluvia and the gravitating principle seem to argue such variety. Perhaps the whole frame of nature may be nothing but various contextures of some certain ethereal spirits or vapors, condensed as it were by precipitation, much after the manner that vapors are condensed into water, or exhalations into grosser substances, though not so easily condensable, and after condensation wrought into various forms, at first by the immediate hand of the Creator, and ever since by the power of nature, which, by virtue of the command, increase and multiply, became a complete imitator of the copy set her by the protoplast. Thus, perhaps, may all things be originated from ether. This last sentence is particularly significant, for by reducing all matter to ethereal condensations and regarding the ether as constituted by minute particles, Newton had the idea that possibly all phenomena could ultimately be explained in terms of attractions and repulsions between these particles, and thus a complete mathematical description of the world be given. Besides requiring the ether to explain the phenomena described above, Newton required it to serve two other purposes. He required the ether to account for gravitation, and also for the fact that the universe is not at a standstill. On this latter point, Newton remarks that inertia, or vis inertiae, as he calls it, is a passive principle by which bodies persist in their motion or rest, receive motion in proportion to the force impressing it, and resist as much as they are resisted. But he goes on. By this principle alone, there never could have been any motion in the world. Some other principle was necessary for putting bodies into motion, and now they are in motion. Some other principle is necessary for conserving motion. For from the various composition of two motions, 'tis very certain that there is not always the same quantity of motion in the world. But by reason of the tenacity of fluids and attrition of their parts, and the weakness of elasticity in solids, motion is much more apt to be lost than got, and is always upon the decay. For bodies which are either absolutely hard or so soft as to be void of elasticity will not rebound from one another. Impenetrability makes them only stop. If two equal bodies meet directly in vacuo, they will, by the laws of motion, stop where they meet and lose all their motion, and remain in rest, unless they are elastic, and receive new motion from their spring. If they have so much elasticity as suffices to make them rebound with a quarter, or half, or 3/4 of the force with which they come together, they will lose 3/4 or half or a quarter of their motion. And not only such cases, but the heat of the sun, and the beating of the heart, etc., are all expenditures of energy which require to be kept up. They are kept up by what Newton calls active principles, and that's it.